Okay, so I'm on step 3 here. So since we're testing standard deviation of a population, I'm going to use the chi-square test. So the formula for that is chi squared is equal to the quantity n minus 1 times s squared over sigma squared. So that's going to equal 22 minus 1 times s, which is 0.044634. Now it looks like a lot of decimals, but we had to put the data in our one variable stats to figure out what s was, divided by 0.04 squared. So again, to find this s, I put the data that was given to me for my sample into my one variable stats, and I ran the one variable stats and I looked what s was. And I take 4 decimal places so I don't make any rounding errors. So that equals 26.148. Okay, so chi squared is equal to 26.148. Now what we're ready to do is look at what our graph looks like. Remember, chi squared is skewed to the right, like that. It's a right tail test, and there's 0.05 in the right tail. And when you look up the chi-square value, I'm using degrees of freedom equals 21, so it's 22 minus 1. And when I look that up on my chi-square table, I find that that's equal to 32.671. The area in my right tail is 0.05, my degrees of freedom is 21, and I get 32.671. I look up where my value of 26.148 lies, and it's right here. My stylus is not wanting to pick up. I don't know why. It's right here to the left of my critical value. So therefore, I'm going to accept H naught because I'm in the clear. And I'm going to accept H naught because 26.148 is less than my critical value of 32.671. So again, therefore I'm in the clear. Since I accepted H naught, when we get to step 4, we realize we are going to reject our claim, and so we will say there is not sufficient evidence. So I'm going to just stop right there and let you finish. There's not sufficient evidence to show that, blah, blah, blah. Okay, so that helps you on 10-4.